Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss about resource allocation graph in detail. So I request everyone to watch the complete video for better understanding. In a resource allocation graph, you have two types of vertices and two types of edges. First, let me discuss about the vertices and then I will discuss about the edges. Look at here, you have two types of vertices such as one is represented using the circle and another one is represented like this. Now whenever you have a representation in the circle, then it is called as a process. So you have two processes such as P1 and P2, and you have two types of resources such as R1 and R2. Now in the resources we have single instant resources and multiple instance of resources. If it is a single instance resource, we will represent like this. If it is a multiple instance of resources, meaning is that, look at here, if I represent three dots of resource R2, meaning is that three instances of resource R2 are available. Now if I represent like this with a resource R1, then meaning is that single instance of resource R1 is there. Are you able to understand? So now look at here, you have one instance of resource R1 and two instances of resource R2. You can represent single instance like this, or simply you can represent like this also. And then coming to the edges, you have two edges, okay? One is the allocation edge and another one is the request edge. How I will represent that one is, let's take that you have a resource R1 and the process P0. Now if there is an edge from resource to the process, resource R1 to the process P0, then meaning is that resource R1 has been allocated to the process P0. So this edge represents the allocation. Similarly, let's take that you have resource R1 and there is a process P1. If there is an edge from process to the resource, then meaning is that process P1 is requesting for one instance of resource R1. Is it clear? Let's take that you have two edges. Then meaning is that process P1 is requesting for two instances of resource R1. Is it clear? Whenever there is an edge from process to the resource, then it is requesting. Whenever there is an edge from resource to the process, then allocation. Is it clear? So with this introduction, now we will discuss two examples related to the resource allocation graph. With the resource allocation graph, we can find the need and allocation and the availability, and we can check whether the system is in safe state or not. Is it clear? Look at the first example. In first example, you have two processes such as P1 and P2. Is it clear? Now let me talk about the allocation. Is it clear? We have two types of resources, R1 and R2. Now look at the resource allocation graph and find the process P1 allocation vector. Process P1 is requesting for resource R2. There is an edge from P1 to R2, so it is requesting. But coming to the allocation, resource R1, one instance has been allocated to the process P1. So one instance of resource R1 has been allocated to P1, so you have to represent value 1 here. Is it clear? Similarly, look at resource R2 has been allocated to P1. There is no edge from R2 to P1, so 0 instance of resource R2 has been allocated to process P1. Similarly, there is an edge from R2 to P2. So resource R2, one instance has been allocated to the process P2. There is no edge from R1 to P2, so this value will be 0. So meaning is that one instance of resource R1 has been allocated to P1, one instance of resource R2 has been allocated to P2. Now we will find the requirement or the future need. Is it clear? Of the resource R1 and R2 with respect to the process P1 and P2. Is it clear? Look at here. When we will say that process P1 is requesting for the resource R1, whenever there is an edge from P1 to R1. Is there is an edge from P1 to R1? See, there is an edge from R1 to P1, but there is no edge from P1 to R1. So P1 is not requesting for the resource R1. Look at here, there is an edge from P1 to R2. Meaning is that process P1 is requesting for one instance of resource R2. Similarly, process P2 is requesting for one instance of resource R1 and it is not requesting for the resource R2. Is it clear? So we got the allocation matrix and the requirement. Now we will find the current availability of resource R1 and resource R2. Look at here. We have one instance of resource R1 and one instance of resource R2. Out of the one instance of resource R1, one is already allocated to P1. So the current availability of resource R1 is 0. Similarly, you have one instance of resource R2 that has been allocated to the P2. So the current availability of resource R2 is also 0. I hope you got this point. So the current availability is R1 and R2. Now with this availability, can we satisfy the requirement of any process? We will see the process P1. Process P1 requirement is 0 and 1. If we allocate the resource, then process P1 can complete its task. Similarly, process P2 requirement is 1, 0. If we can allocate, then process P2 will complete the task. Look at here. The need is 0, 1, but the availability is 0, 0. Meaning is that process P1 needs the one instance of resource R2, but we don't have in resource R2. If we don't have, how can we provide? So process P1 requirement cannot be satisfied. Look at the process P2. Process P2 requirement is 1, 0. Now meaning is that it needs one instance of resource R1, but there is no availability. So process P2 requirement cannot be satisfied. So we don't have enough resources to satisfy either process P1 or process P2. Then meaning is that system is in unsafe state and deadlock will happen. Is it clear? So in this situation, deadlock will happen. Is it clear? Now look at here. There is a cycle. There is an edge from like this, going like this, going like this, like this. So whenever there is a cycle in a resource allocation graph, when the resources all are single instance, then we can say that it is a deadlock. Remember this point. In resource allocation graph, in single instance resources, now resource R1 and resource R2 are single instance and there is a cycle. So we can say that, is it clear? There is a deadlock. I hope you have understood the point. So what I can say that the cycle is necessary and sufficient condition to say that there is a deadlock in single instant resources. Okay, now we will discuss an example on multi-instant resources. Okay, is it clear? We will check whether the cycle is the necessary and sufficient condition to say a deadlock or not. Is it clear? Are you able to understand? So look at the process. We have process P1, process P2, process P3. Is it clear? And we will look at the allocation matrix of how many types of resources are there? Two types of resources are there, which are R1 and R2. Okay. Let me find the allocation vector of process P1. Resource R1 has been allocated to the process P1 and only one instance has been allocated. So I can say that resource R1 has been allocated to process P1. Similarly, resource R2 has not allocated to process P1 because there is no edge from resource to the process P1. So 0 instance of resource R2 has been allocated to process P1. Similarly, look at the process P2. There is an edge from resource R1 to P2? No, there is an edge from P2 to R1. So meaning is that process P2 is requesting for resource R1, but currently resource R1 has not allocated to process P2. Similarly, look at the resource R2 with process P2. There is an edge from resource R2 to process P2. So one instance of resource R2 has been allocated to the process P2. Similarly, look at the process P3. Is there an edge from resource R1 to process P3? No, so it is 0. There is an edge from resource R to process P3, so it is value is 1. We got the allocation matrix. Similarly, we will find the requirement matrix. Is it clear? Of resource R1, resource R2 with respect to the process P1 and P2 and P3. Now look at here. Is there an edge from process P1 to resource R1? No. So requirement is 0. Is there an edge from process P1 to resource R2? Yes. So it is asking for one instance of resource R2. Look at the process P2. There is an edge from P2 to R1. So requirement is 1. Okay. Is there an edge from P2 to R2? No. Is it clear? So which is 0. Are you able to understand? Similarly, look at, is there an edge from P3 to R1? No. Similarly, P3 to R2? No. So, process P3 does not need either resource R1 or resource R2 to complete its task. Is it clear? Now, look at the resource R1 and resource R2. Okay, initially you have one instance of resource R1 and two instances of resource are available, resource 2 are available. Now out of one instance you have allocated one instance of resource R1 to process P1. So the current availability, let me write it as CA, the current availability of resource R1 is 0. Similarly, process P2 and process P3 got one instance of resource R2 each. So you have 2 and you have allocated 2. So the current availability is also 0. So resource R1 and resource R2 current availability is 0 and 0. Now look at here. With this availability, see this is the availability 0, 0. With this availability, can you satisfy any process requirement? Look at the process P1. The need is 0, 1, meaning is that needs the one instance of resource R2, but we don't have. So we cannot satisfy the requirement of process P1 currently. Similarly, can we satisfy the requirement of process P2? No, because it is asking for one instance of resource R1, but we don't have. Is it clear? Look at, can we satisfy the requirement of process P3? Yes. It does not need either resource R1 or resource R2, and we don't have also. Is it clear? So this is the process we can allocate. Okay, obviously we are not allocating, but it will complete the task. If it completes the task, whatever the resources it has, it will release. Is it clear? A process will request for the resource. Once it get the resource, it will use the resource and it will finish the task. Once the task is completed, it will release the resources. Is it clear? So 0 and 1 is the availability with the process P3 and it will release. So the current availability is 0 and 1. Okay, and we have completed process P3. Is it clear? Are you able to understand? Look at the current availability and can we satisfy the need of process P1 or not? 0 and 1, and the availability is also 0 and 1. So we can satisfy the requirement of process P1. Can we satisfy the need of process P2? No. Am I right? Because it is requesting for resource R1, we don't have. So if I allocate the requirement 0 and 1, the process P1 will complete its task and it will release the resources, which is 1, 0. So the current availability will be 1 and 1. Okay, are you able to understand? So you have one instance of resource R1 and one instance of resource R2. We have completed process P3 and then process P1. Now process P2 need is 1, 0 and the availability is also 1, 1. So we can satisfy the requirement of process P2 and then process P2 will complete its task and will release the resources. So it will be 1, 2. Okay, so after executing the process P3, P1 and P2, the availability is 1 and 2. Now look at here. We are able to execute all the process in a sequence as P3, P1, P2. So we can say that the system is in safe state. Is it clear? So even there is a cycle here. Even there is a cycle, there is no deadlock. Is it clear? Are you able to understand it or not? But when it comes to the single instant resources, if there is a cycle, we can say that there is a deadlock. But in a multiple instance resources, even if there is a cycle, there may be a no deadlock. Is it clear? Are you able to understand? Now, let me add little bit complex to this question. Now process P3 is requesting for resource R1. Then its request matrix will be 0 and 1. Oh no, sorry, 1, 0. Am I right or wrong? Because process P3 is requesting for resource R1. Okay. Now look at here. Initially, we have one instance of resource R1 and two instances of resource R2. Is it clear? Now, current availability. One already has been allocated to the process P1, so the current availability is 0. And two instances we have, and they are allocated to process P2 and process P3, so it is 0. So the current availability is 0 and 0. Now, can we satisfy the requirement of process P1? No. Am I right or wrong? Process P1 requirement cannot be satisfied. Similarly, can we satisfy the requirement of process P2? No. Can we satisfy the requirement of process P3? No. So, with the current availability of resources, we cannot able to satisfy any one of the process requirement. So, I can say that system is in unsafe state. So, there is a deadlock. So, what I want to say is that in a multiple instance resources, if there is a cycle, there may be a deadlock or there may not be a deadlock. Is it clear? In the next video, I will discuss one gate question which came in the year 1994 related to the multiple instance resources, so that whatever the doubts you have, all the doubts will be cleared. If you still have any doubts related to the resource allocation graph, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.